What's up, everybody? Thank you so much for coming. My name is Kevin Jones. I am a DevRel engineer working for the Graph. I work for Edge and Node, which is one of the core developers. I'm going to be talking to you guys today about why you should use the Graph, why it's important to have some data indexing, talk a little bit about how the Graph works, and how you can configure a subgraph really quickly. We'll try to build one as well using the Graph CLI. My name is Kevin Jones, again, based here actually in the San Francisco area, but you'll see me at a lot of events. Happy to answer any questions afterwards, or if we have time, I'll answer questions. So again, basics of like what is the graph and why you need it. We're going to show the configuration and the architecture and then do a demo. So first of all, why do we need data indexing? I think we know that like for something like Google or some of these larger search engines that are very Web 2, it's to categorize and make information easy accessible by searching. Same goes for crypto. Blockchain data is pretty complicated, and the fact is that you really need a way to easily access that data rather than using the built-in tools that are on the blockchain itself, like the RPC is what I'm referring to. And so if we talk about blockchains are incentivized for transactions, right? You write transactions to the blockchain, you pay some gas. If you're a good smart contract developer, your smart contract emits events, right? That lets your front end know what's going on. And then these are kind of like cheap logs, right? We're able to kind of send some data and keep things aware from a global decentralized perspective. But these can get commonly or kind of lost on the blockchain if they're not categorized in a way that's easy to access. So we look at like an example, simple NFT, right? This is the CryptoPunks contract. All the CryptoPunks contract is a list of the IDs, the punks, who their current owner is, and then where the metadata, which is all the off-chain data, right, sits. So this is a very basic use case of kind of using the blockchain as kind of a little bit of a database. And as these owners of the contracts change hands, we need a way to be able to know what's going on and know who owns a punk at a particular time. But there's some problems when it comes to getting data using the standard like interface, the RPC interface. The first of all is there's just a lot in one given block. There's lots of protocols that are like, inside of a full block. And so it can be very difficult to just look up, like you have to know exactly what contracts for each protocol. In other words, like Uniswap, how many contracts are there? What are all the addresses? Keep those in your application and query them. And if you're trying to get lots of data from that particular protocol or multiple protocols, it's really hard to do. And we also have this idea of like an initial dapp where you have a user interface that you deploy with something like IPFS or Arweave, and you have the application sitting on the blockchain. And for writing, like I said, to the blockchain, using gas, paying for the gas, using the whatever consensus algorithm to secure your transaction is great. But when it comes to reading from the blockchain, technically, the RPC is not designed for reading. It originally was used as a tool for people to query their node and do some kind of interesting things to see what was going on with the blocks. It's never really been truly, created to solve this kind of data problem. We also have this problem with provenance. So how do we get like historical data from the blockchain? How do you know like what exact block number that someone sold their punk to another owner or transferred it to an exchange or whatever it is? There's no way to get that information, right? So what we really want is something like the time machine where we can go back in time and see historically. Does anyone remember time machine? Show of hands. Did anyone ever use it? I used it a little bit. But it's kind of a cool idea, right? You go back in time and see what's going on. We want to do the same thing with the graph. We also end up with like something like this, where someone wanted to see all of the NFTs in a wallet, which is like, this is definitely not an ideal way to do that. But if a user only has like 2 NFTs, it's great. But if they have hundreds of NFTs, it's going to be making hundreds of RPC calls to the node or to the RPC endpoint, and that's going to be very inefficient, as this is just trying to loop through and get all that data. So this is where the graph comes in, right? So we know the problems. The graph is over 200 indexers across the world that are indexing data. It's what are called subgraphs. There's delegators who provide stake. There's curators who provide GRT to incentivize people to pick up that data and store it. And there's this is a wrong number. It's actually closer to like, I think, 10,000 subgraphs now. So there's lots of dApps using the protocol in a decentralized way. And there's a large amount of queries that go through the network as well. And so the idea is to take this, mess of a blockchain and create subgraphs for protocols and for dapps. And so create these subgraph configurations, which are basically databases with an API associated with them. So show of hands, who knows what an API is? Everybody? Who doesn't know what an API is and wants me to explain that? Basic understanding? Okay, cool. So what we want to do here is do something like this instead. Instead of doing that for loop, we can make one GraphQL query in one HTTP request and get all of the same data using the graph, right? And this is kind of the real beauty of the graph is everything is built around GraphQL. And if you're a front-end developer, you know that GraphQL is perfect for front-end development and especially for hackathons. So this is kind of what it looks like. User interface you still have. You have an indexing protocol instead of the graph for reading that data and indexing it and storing it. And you still are writing to the blockchain for all of your secure writes, paying gas and all that good stuff. Okay, let's look at the configuration. So the subgraph configuration is essentially 3 files. We will look at these files in a little detail, but you can think of it like this. The manifest is like the high-level configuration file. Just like any software, you need this high-level configuration file that keeps track of like what you care about. So what network you care about, what entities, how you want to store the data. It keeps track of the address. It keeps track of like how you want to handle processing data. And it kind of references these 2 other configurations. So it references the entities and it references the WASM handler, okay? The entities are how the data is stored. Like in other words, if you create an event, the event is emitting a data type and some data. The entity needs to be relational to how the data is coming off the blockchain's event. So you can think of it like how that data needs to be available to your front end with those proper data types, like integer, unsigned integer, string, Boolean, address, whatever it is. So that entity is actually a GraphQL thing, but it's basically, we'll look at it, but it's basically like a table. You can think of it almost like a database table and how you want to store that data. And then the third part is like this assembly script. So assembly script is a subset of TypeScript. So it's not quite TypeScript, but it looks like TypeScript. It has type safety, but you can't do like imports of like TypeScript stuff. You can only import the stuff that we support, which is like the GraphTS and a couple other things. But it allows you to create a WebAssembly module that processes the data, okay? And so that's what actually stores the data in the database, and that is what is used to listen for the events as they come off of the blockchain. So you can think of it like this. The blockchain application that you have, the smart contract, emits events. You also might have like an IPFS hash or something that's emitted for Arweave that tells you how to get the data from Arweave for it. So let's say it's like an NFT. So we can do off-chain data. And then the WASM will process that data as it comes off, or it will go out and get the data from IPFS or Arweave based on the event. And then we store that stuff with Postgres in the database, okay? So the data is actually stored on the indexer inside of a database. And then for the indexers, they also run a copy of what's called GraphNode. So GraphNode is a Rust implementation of basically, it's what runs the WASM modules and makes sure that they're running to process the data. And it's also what exposes the data in a GraphQL endpoint. So imagine your user or your consumer is going to your application. They're making a GraphQL request, giving that to the GraphNode over the API. The database is then responding with the appropriate SQL query data and then serving that as a GraphQL response. So it's kind of like middleware. That's the best way to think about it. So again, just review. This is like probably the best diagram I know that we have of explaining it, but you have a dapp, right? You build your dapp, Next.js, whatever, React, whatever it is, JavaScript, CSS, HTML, doesn't matter. You're still proposing transactions to the blockchain. You're still using that gas that you pay to change the state. The smart contract is emitting events on the right, and as they get picked up by GraphNode, using the WebAssembly module, the rules that you have defined inside of that module, they're stored inside the database, and then they're exposed with the GraphQL API, right? So then your dapp is just able to query that GraphQL endpoint directly. Another good use case for you guys, if this is who's your first hackathon? Anyone here first one? First one? Oh, perfect. Okay. This is a cool package. It's called Scaffold.eth. There's a special extension for it. All you have to do is add -e subgraph, and you will get a copy of Next.js, Hardhat or Foundry, and a subgraph repo that has a subgraph already built for you for the contract that comes with Scaffold.eth. So if you're just starting out, this comes with everything you need to qualify for the bounty. You just need to make changes to your subgraph and make changes to your smart contract that relate, and you can get started quickly building a dapp. I'm going to use it in my demo, but we'll go from there. There's also a Telegram chat. Everyone who wants help, we have a booth. We'll be there. For some reason, there's no one there. Should join the chat. There's not a chat channel yet, but we will create that right now. There should be a general one, though, so if you have questions, you can ask in there. Anyone need to scan that? Cool. There's also cheat sheets. I don't know if we have them here. We probably don't have them here, but they're at the booth. Those are going to be super useful. You should come grab one. They're going to help you get started pretty quickly as well. Okay, let's do it. So I got 9 minutes for a demo. Cool. Okay, so I am basically going to I've already deployed an application with Scaffold.eth. I put it on base mainnet. It's a very basic contract. We can look at it right here. Well, actually, we can look at it in VS Code because it's a little nicer. It's like a hello world contract. The only thing you need to know about it is that it displays a greeting. This is the contract that comes with Scaffold.eth. It displays a greeting called Building Unstoppable Apps, and then it emits an event anytime someone changes the greeting. So if they come in here and set a new greeting, they kind of shout something, then it emits the event, right? It's a very basic smart contract, nothing crazy. So I've already deployed that, and if we come over here to Scaffold.eth, we can see that it's actually deployed to base. It doesn't have any balance, but it has a string of hello ETHGlobal San Francisco, right? So we want to index the data for this contract. I also verified the contract already. So if you click here on contract, you should verify your contract before you deploy it, or after you deploy it, not before, you can't. But after you deploy it, you should verify it because the CLI will reference the ABI to make sure that it understands all of the events that are in there, and it will automatically build you a subgraph. If you don't verify it, you have to pass the ABI in the CLI, and I'll show you what that looks like right now. So if you're going to get started on the graph, and let's say your smart contract developer has built the smart contract, or you've built it, and you want to build a subgraph for it, you come here, you go to thegraph.com, you go to products, you go to the subgraph studio, okay? This is where you go if you want to build a subgraph, okay? If you want to query a subgraph that's already out there, you can go to the Explorer, okay? So it kind of depends on what bounty you want to get. There's 3 bounties. There's the best use of a subgraph, there's the best new subgraph, and then there's, I think, best substreams. So there's 3 different ways that you can qualify. I'm not going to talk about substreams today, but you're more than welcome to come by the booth and I'll explain some things about it or afterwards. So really, if you're going to get the new subgraph, you should be going to the studio. So let's do that. Let's go to the studio. You'll sign in. So if it's the first time you've ever been here, you should sign in. You connect your wallet. It's going to ask you to sign a message, create an account, and you'll get on this thing. You'll get a free plan with 100,000 free queries. Oh, for some reason I have 200,000. Sweet. And I will say create subgraph. I will name it. So we'll do it ETHGSF or something. I don't know. There we go. It will create it here. You click it. Okay. You install the CLI. So it gives you all the commands here. This is kind of like a skeleton, like a bare bone skeleton for you to start building. So you come over here. You can install this CLI with NPM or Yarn. So let's just say we do Yarn. I've actually already done that. So let's skip that. Then you do a graph init. So we come over here. We do graph init. That's going to spin up a new subgraph on my local machine. So I'm in my terminal right now. I'm going to go to Ethereum. I'm going to call it ETHGSF. I'm going to go down and choose my network. So in this case, it's base. If I can find base, where's base? Here it is, base. And then it wants the contract address. So if you've deployed your contract, it's available, right? You know what it is. You're verified. Go here to contract, grab the contract, paste it in. It's going to try to fetch the ABI. It might have issues on certain chains, so you might have to provide the ABI. So if you want to do it manually, you say no. It's also going to try to fetch the start block. If it can't find the start block, you might need to add it manually. I'll show you how to get that, so we'll say no. So where is the ABI? Well, I have it in my project here. So it's inside of the artifacts, I believe. No, sorry, it's in deployments. Here it is. So here's the ABI. So I have that. You'll need that if you are on a chain that isn't pulling it automatically. Ethereum mainnet, it should, or like Sepolia, it should pick it up. So you should be fine. So I'm going to copy the path, paste it in. The start block is available on the block explorer. So you can see here, this was the transaction of when this contract was deployed. We can click it, and then we can get the time that it was deployed. So this was the block. So I can grab that, paste it in, name contract, index of entities is true, yes. You always want to say yes, because that will build out the subgraph for you. 4 minutes. Let's do this. This last part's going to be a little bit of a speed run because I'm going to have to fly through the explanation. But okay, add another contract. No. I'm going to go into that folder, so ETHGSF, and I can take a look at the code. Let's look at it real quick. So I mentioned earlier, there's a subgraph YAML, which is like the high-level configuration file. It automatically generates this as long as you provide the ABI, and as long as you, if you verify your contract, it might do it automatically. Otherwise, give it the ABI. This tells you what network we're on. So we're on base. We have the address. We have the start block in here. We have the entities that are automatically created based on your events. We have the handler, which processes the data, right? Those 3 things I told you about. So if we go to schema, we only have one entity, and it keeps track of the ID, which is like the actual ID of the unique identifier, which is generated. It has the who sent the greeting, what the greeting was there a premium paid, was there some value in the transaction, what was the block number, the timestamp, the transaction hash, and all the data types that we know we need to use based on the ABI. And then inside the source folder is the contract TS. And this is where the handler is processing the data. So we import the schema, we import the contract and the event. And then when an event comes through, creates the entity using the new function here, creates what the ID should be, the hash, and converts it to I32. And then we set all the values as they come off of the block. So the event parameter for the greeting, for the new greeting, the greeting setter, the new greeting, what the premium was, or did they pay a premium, what was the value in the transaction, what was the block number, the timestamp, and the transaction hash. Okay, so let's deploy it. So I'm going to do it real quick. Subgraph Studio, auth, did I already do that? No, I didn't do that. Let me auth. I have to authenticate, then I can build. So this is going to generate the types for me so that I can interact with the contract, and it's going to build the WASM module, and then all I need to do is deploy. So it gives you all the commands. You literally just have to copy, paste, copy, paste. So version, this is the last part. It asks you what version you want. Let's do version 1. Now it's going to take the subgraph, deploy it to the network. Now it's going to deploy it to the studio, I should say, and then it's going to give you the API endpoint, but we can also grab it just from the studio up here. So now it's synced 100%. We can go to Playground, and we can start getting the data. And there it is. So I only have one event, and it's hello, ETHGlobal San Francisco. I didn't pay any value, and I was the one who set the transaction. Cool. So you get the idea. It's pretty easy to get started with the graph. You just need to come onto the Graph Studio, create a subgraph, follow those commands, and it will build the subgraph for you. We obviously want you to do more than that. Like, you should probably do some interesting things in the subgraph. There's tons of features and functionality. But yeah, hopefully that was useful. I have time for one question. Who wants it? Not one question? Yeah. So when I deployed this one, the question was, where does the subgraph live? In this case, I'm deploying it to the studio, which is a special setup that we run to run it like a development environment. When you eventually publish it to the network, it goes onto the decentralized network. But here, it's on a special kind of like development instance, but it's not on your local machine. If you use the subgraph extension of Scaffold ETH, that will give you a Docker container that you can run locally. And that's an option. Cool. I'm going to step outside and answer any more questions you guys have, but thank you so much. Appreciate it.